Okay. So kita refer buku Dr. Kamarudin. Okay. Uh, I guess this is not the latest version lah. Tapi because Dr. Kamarudin has include a new, what we call it, a new, some new example on this the new reference book. Okay. So this is the previous one, okay, that I have. Okay. So we go through for the introduction part. Okay. So consolidation settlement. Total settlement is a ground due. Total settlement of a ground is due to the external load or pressure is contributed by the elastic settlement and consolidation settlement. Okay. So previously, I add the secondary settlement. Okay. So, but in this topic, we only learn for the elastic and consolidation settlement only. Okay. So, elastic settlement is generally more profound in the granular material, whereas consolidation settlement is more important in saturated cohesive soil. Okay. So, as we have discussed previously, okay, on the elastic settlement, okay, it's more significant for the granular or like sand or gravel material, and normally sand. Okay. While for the consolidation settlement is more important in the clay material. Consolidation is defined as the reduction in volume of saturated soil, okay, due to the applied pressure, resulting in the dissipation of excess pore water pressure and expulsion of pore water from the voids. Okay. So the keyword is reduction in volume of saturated soil. Okay. So it's only happen on the saturated uh, soil, okay, which is represent the clay material. Okay. Due to the applied pressure. Okay. And the process is due to dissipation of excess pore water pressure and expulsion of pore water from the voids. Consolidation settlement can be estimated depending upon the history of the clay. Okay. So the stress history on the clay, okay, can be divided into normally consolidated clay or over consolidated clay. Okay, the following equation may be used to calculate the consolidation settlement of the saturated clay. Okay. So for normally consolidated clay, and see where the maximum past effective vertical stress equal to the present effective stress. Okay. Which is the PC is equal to sigma C. Okay, Dr. Kamarudin used PC, while our previous example in the slide used the sigma C. Okay. So this is the equation. Okay. For overconsidered clay OC, where the maximum past effective stress is greater than the present effective stress, which is the PC is greater, okay, or the sigma C is greater than sigma naught. The calculation of the consolidation settlement may involve either two of the following cases. Okay, so as we have noticed previously, okay, so we have here, if the sigma naught plus delta sigma is less than equal, okay, then the PC. So this is the formula. Okay, if PC is less than sigma plus delta sigma, so this is the equation 2.3. Okay, okay, a little bit different between the slide, the equation in the slide for the 2.3. Okay, where Dr. Kamarudin introduced the delta sigma 1 and delta sigma 2. Okay, so for me, it is easy to use the example in the slide rather than use this equation 2.3. Okay. So then we look on the notification, okay, where the delta H is the consolidation settlement. Okay. or you can use the SC. Okay. H naught is the thickness of consolidating layer. This is the H naught. E naught is the initial void ratio of the consolidating layer. CC is the compression index. CR is the rebound index. Okay. Sigma naught is the effective vertical stress at the mid plane. Okay. So as I told you before, if we use the full height of the clay layer, so maybe we may over predict the settlement value. So that's why they use at the mid plane of the consolidating layer. Delta sigma is the increase in the stress at the mid plane of the consolidating layer. Okay, so then we just omit this one, delta sigma 1, delta sigma 2. Okay, for me it's preferred to use the formula on the slide. Okay, so you can get my slide in the e-learning. Okay, if I'm not mistaken, I already uploaded. Okay, in the e-learning with the YouTube link as well. Okay. Okay. Okay, then the Dr. Kamarudin explain what is the delta sigma 1, delta sigma 2. Okay, where delta sigma, okay, 1 is the stress from not sigma naught to PC, delta sigma 2 is delta sigma minus v delta sigma 1. Okay, so you may refer to this diagram to understand more on the delta sigma 2 and sigma 1. Okay. Then 2.5 is the equation, okay, for the delta sigma by using delta H by using the MV approach. So in here we have sigma naught plus multiply with MV multiply with delta sigma. Okay. So other parameter that are related to the consolidation are degree of consolidation, UV, time factor, TV, coefficient of consolidation, CV. The relationship between TV, UV is shown in figure 2.2. Okay. The equation to determine the coefficient of consolidation according to Zaghi one-dimensional consolidation theory is as follow. Okay. So this is the equation. This is the formula for the CV, which is equal to TV times HD power by 2 over T for the 2.6 equation. Okay. So this is the relation as we have discussed previously. Okay. Note that HD depends upon drainage condition, whether single or double drainage. For single drainage, water is allowed to flow either upward and downward or downward only. The longest drainage path equal to the thickness of the consolidation layer. On the other hand, the longest drainage path is a path of the consolidation layer in the case of the double drainage. Water is allowed to flow in both upward and downward direction. Okay. So now we move to the example number 1. Okay. So from this example, okay, we may learn in terms on how to calculate to determine the void ratio value. Okay. Okay. So a 29.27 millimeter thick saturated clay sample with the specific gravity and moisture content of 2.65 and 39.58 respectively was subjected to a double drainage one-dimensional consolidation test. A pressure of 8 kilonewton over meter square was applied for 24 hours and the settlement of 2.36 millimeter was recorded. Determine the void ratio and moisture content of the sample after the test. Okay. So for saturated clay, changes in thickness and void ratio can be represented by the phase diagram shown in figure Q21. Okay. So this is before the compression and this is after the compression. Okay, so delta E is the change of the void ratio. Delta H is the change of the height of the sample. Okay, so E naught is the what we call it is the initial void ratio. Okay, because the condition of the soil is fully saturated, so there are no air contents. Okay, air void contents. Okay, so assume that solids, okay, is equal to 1, okay, where the HS is the height of the solid, while this is the height of the voids. Okay, so after the compression, there will be a delta E and E not E1, E final, or E after compression, while they have a delta H, okay, and the H1, okay. Okay, so assuming the height of the solid HS is equal to 1, okay, then the void ratio, okay, the void ratio is the VV over VS, okay, because the ratio between the voids over the ratio between the volume of void over volume of solid. So actually you have learned during your soil mechanics subject. So VV is volume of void over volume of solid, okay, is equal to the height of the volume, height of the void over height of the solid. Okay. So since HS is equal to 1, okay, so since HS is equal to, sorry, okay, since HS is equal to 1, okay, then the void ratio is equal to H, okay, this is equal to HB over HS, okay. So since VS is equal to HS is equal to 1, okay, so then the initial void ratio E naught before compression is equal to VV equal to VS, okay. So on the initial stage, okay, they assume HS is equal to 1, okay, due to the uh, due to the void ratio, okay, sorry, due to the volume of solids is equal to the height of the soil, okay, so Vs is considered equal to 1 as well. Okay. Then the initial void ratio is equal to VV and also equal to HV, okay, before compression. Okay. So applying the concept of strain, okay, the following equation can be established. Okay. So strain is the difference or deformations over actual length. Okay. So we use the concept of strain, okay, where the delta H, okay, is over H naught. Okay. So this is delta H is over the H naught. Okay. Equal to delta E over 1 plus E naught. Okay. Okay. So then, okay, so this is the Okay, so we use this equation, okay, in order to get what will be the delta E later on. Okay, from there we can get what will be the void ratio after the compressions. Okay, determine the void ratio, okay, after the test. Okay, so by using this equation, okay, the delta E is equal to delta H over H naught multiply with 1 plus E naught. We need to determine E naught first before calculating the delta E. Okay, with delta H and H naught unknown. Delta H is equal to 2.36. Okay, that is delta H. Okay, while H naught is equal to 29.27. Okay, but for the E naught, delta is equal to sorry, E naught. Okay, E naught can be found using the equation from solid mechanics, which is W times GS is equal to S R times E. Okay, due to the degree of saturation is equal to 1, so E is equal to WGS. So in our case, W is equal to 0.3958. Okay, the initial moisture content. Okay, times with the specific gravity 2.65. Okay, 2.65. So then we obtain 1.05. Okay, then we can calculate for the delta E. Okay, delta H 2.36 over 29.27 times 1 plus 1 over 0.5. Okay, so then the delta is equal to 0.17. Okay, so the final void ratio, which is the difference between the initial void ratio with the delta E. So the final void ratio is equal to 0.8, 0.88. Okay. So that is for the final void ratio. Okay. While for the moisture content after the test, okay, by assuming the soil is fully saturated, so the SR is equal to 1. So E is equal to the final void content, a void ratio, over specific gravity. So 0.88 over 2.65 is equal to 33.21. So that is for the moisture content value. Okay. So that is for the void ratio determination and also the moisture content determination. Any question? Ada? Tak ada eh? Okay. So I move to the second example eh. Okay. Okay. For the second example, a soft clay layer as a proposed project site as shown in figure Q22 is to be compressed by preloading. Okay. The dimension of the embankment is 100 meter times 100 meter and the unit weight of the fill material is 16 kilonewton per meter cubes. Okay. So we have here 100 times 100, okay, diameter of the embankment with a unit weight of 16. Okay. Okay, the first thickness of a clay sand with a thick of 5 meter. Okay. So if we read on this name, so actually the dominant material is the last word. Okay, so clayey sand is the dominant, so it is a sandy soil material. Okay, so for the soft clay, definitely it is a clay. Okay, so the thickness of the clay is 20 meter with these soil properties. Okay, unit weight, C and Phi, and and below the soft clay is a sandy gravel. Okay, so we can assume that it is a double drainage. Okay, because this water can moving upward and also moving downwards. Okay. A. Calculate the effective vertical stress at the midplane of the clay layer before the placement of the surcharge. Okay. So the first question, okay, what will be the effective vertical stress at the midplane of the clay layer? Okay. So 5 meter times 18 and should minus with 10. Okay, so that is for the clay sand. Okay, at the middle, so we divide into 2, so 10 times 19 minus 10. Okay, so that is for the effective vertical stress at the midplane for the clay layer. So it is 130. Okay. B. Determine the required height of the embankment if the stress increase to be achieved at the midplane of the clay layer is 60 kilonewton per meter square. Okay, use 2/1 methods. Okay, so we need to know what will be the height of the surcharge. Okay, we only know the area of the surcharge, which is 100 meter times 100 meter. Okay, so by using the 2/1 methods, okay, um, at the mid plane area, okay, the pressure is around 60 kilonewton per meter square. Okay, I need to find on how to write. Okay, okay. Wait, I need to open in on different slide. Yeah, on different PDF mode. Alah sama. Okay, okay. Okay, determine the required height of the embankment if the stress increase to be achieved at the midplane of the clay layer is 60. Okay. Use 2/1, 2 to 1 method. Okay, so the 2 to 1 methods, actually, I guess you have learned on the chapter 1. Okay, so the formula is, okay, this is the formula. Okay, so this is the formula for 2 to 1 methods. Okay, okay. So uh, the increment of stress at the depth of y is equal to 60, okay, 60 here, okay, and the thickness up to the middle of the clay layer, okay, is 5 times 10 is equal to 15. Okay, y is equal to 15. Okay, okay. So then you need to rearrange, okay, to get what is the Q value. Okay, so the Q should be put on the left while the delta sigma will be moved to the right. Okay, and this is the new equation. Okay, so delta sigma is equal to 60. Okay, B is equal to 100 plus Y is equal to 15. L is equal to 100 plus 15 over 100 times 100, which is equal to 79.35. Okay, so that is for the Q. Okay, so now we know what is the Q, okay, on the top of the soil, which is 79.35. We need to determine what is the height of the embankment, okay, which is represented 79.35 on the soil layer. Okay, so the applied pressure Q is the product of the weight, unit weight of the material and its height, which is Q is equal to unit weight of fill material times H height of the fill material. Okay, so then rearranging uh, uh, where the height is on the left and the rest will be on the right. So Q is 79.35 over the unit weight of the fill material. Okay, unit weight of the fill material is 16. Okay, so then the height of the fill material is equal to 4.96 or equivalent to 5 meter height. Okay, so that is for the height of the embankment. Okay, so the last one, how much is the expected consolidation settlement of the clay if its compression index and initial void ratio are 0.62 and 1.05 respectively? Okay, so we need to know first what is the condition of the soil. It is normally consolidated or over consolidated type of material. Okay, okay, so the consolidated settlement can be determined using, okay, so from this equation we can know that this is the normally consolidated equations. Okay, or in terms of logic, okay, let's say this is it is a flat ground. Okay, then before we apply for any surcharge, okay, there are no previous loading on the top of the soil. Okay, so in that case, the pre-consolidation pressure is equal to the existing vertical effective vertical stress. Okay, so then later on we apply the surcharge. Okay, so it is a normally consolidated case. Okay, then I will explain later on. Okay, if we have a over consolidated case. Okay, so H naught is the thickness of the clay layer. Okay, in this case the clay layer is 20 meter height or thick. Okay, then 1 plus E naught. Okay, E naught for the clay layer is Okay, it's given here 1.05. Okay, and CC is equal to 0.62. Okay, CC 0.62. Okay, times a log effective vertical stress plus delta sigma over effective vertical stress. Okay, so 130 plus 60 over 130. So the delta sigma is the pressure at the mid plane. Okay, so it's already given in the P. Okay, pressure at the mid plane is 60 kPa. Okay, so then the value for the settlement is equal to 1 meter. Okay, so 1 meter is the value of the settlement for this case. Okay. So we have example number 3, example number 4, example number 5, 6, and up to example number 7 here only. I'm not sure how many example in your new reference book. How many? Hello? Oh, banyak ada? Hello?